project is the White Cell Code, and I'm Brian Urias.
And I'm Gabrielle Sims.
So, our objectives for this project are to actually take the way that companies are currently developing antivirus systems and programs and actually put a spin on it where the antivirus learns how to solve a virus or how to clean it by itself, and then it will correct it and then send updates to other systems with the antivirus program on them. This could potentially generate actually different, I guess, perspective on the software industry, because Google is also investing a lot of time in self-learning programs, and they're getting like really, really advanced.
Okay, so in order to understand the white cell code, you have to first understand what is a white blood cell. So the scientific name of a white blood cell is a leukocyte. So we know that white blood cells circulate the body through the bloodstream. So when you get a cut, like even whether big or small, the first thing that you see is blood. And what that blood is doing, the white blood cells are actually attacking so that no germs from on the outside could get into your body. So that would be a neutrophil. But what we're hoping, that's how all antiviruses behave. They attack the virus when it comes. We're hoping to generate a lymphocyte, which actually creates an antibody. Meaning that when the virus comes to your computer, our virus would learn how the virus behaves just like an antibody would, and be able to attack again when it comes again.
Alright, so the way that antiviruses work is that they have a list of definitions, which is basically a set of instructions on how to remove a virus or how to clean it up or isolate it. But if you have a virus that is not defined or nobody has seen before, because I decided to make my own virus and create it in my laptop and then put it on a school computer and then infect the whole school, there's no actual list or there's no definition for it, so it means that it's not actually solvable at the moment. So the antivirus has to send an error request to people that are actually solving like how to fix and repair those viruses. So it may take days or weeks, like depending how complicated it is.
And so imagine how much days and weeks, how much computers that virus could have attacked. Whereas our learning virus would be able to, when a new virus comes out, it'll be able just to learn its abilities, send an update to us. We're not updating the virus, unlike other antivirus companies does. The virus updating itself and telling us when this new virus comes about. You don't have to keep track of anything. You just have to keep track of the new viruses that are coming with our antivirus is telling us. So in order to understand our white cell code, you also have to understand what is a code. The code is the language between the computer and us. Computers don't speak German, English, anything. They speak code. And code is a mixture of numbers, letters, and symbols.
Alright, so the way that our learning antivirus works is first you introduce the section of code or the program or whatever you want to scan into the learning antivirus. And so, for example, if I have this piece of code, it's just a simple program for a Raspberry Pi. And I say, okay, I want to infect this program. I want to plug in the word Zika every 5 letters. So every 5 letters, I introduce the word Zika into the code. That completely breaks it, and there's no way that the antivirus, or any antivirus currently, can solve it. So the way that we can solve it is we can learn from patterns and from like the current way that viruses behave, ways to solve it, and then the antivirus says, okay, so this is wrong with it. Let me do this to the code and then fix it. And then it says, okay, well, every other computer that has this program installed is going to say, okay, well, now there's an update, and now it's not going to affect any other computer.
And the way our antivirus will know this is because the same way your antibodies attack any foreign substance, if we know that this code is not supposed to have Zika, we know that this Zika word came out of nowhere, the antivirus would look at it, read it, and say, yo, this is a virus, I gotta attack it, just like a white blood cell it would. Update every other computer, create an antibody to fix it, everything. That's what our antivirus hopes to do. And of course it attacks and repairs it. And then of course it learns it and everything else.
Alright, so the current companies that are at the greatest share of the antivirus market are Norton, McAfee, EVG, and Malwarebytes. Malwarebytes is usually more popular because it's free, but Norton is more for companies because it's, it's relatively well structured and everything. So this could apply to almost any antivirus out there. These are.
Hey, all right, questions?
Did you think about a network structure, for example? Like you have a body, you have your white blood cells in your body, you cannot share it with him. But since we are in a network, let's say, we can share this beautiful product with other computers, right? So maybe you may want to look at worms as your target, and you can create something like anti-worm, which can go around the network and cure everyone.
That's kind of the way that we're trying to go, because if there's like a worm that is introduced in a computer, and then it's detected, the antivirus will say, okay, this is what it's doing, let me prevent it from doing that, or let me isolate it and attack it, and then figure out how to send that information on how to prevent it to every other computer with the program in it.
That's cute. Anyway, me being zero algorithm, whatever, how do you actually make the algorithm so that it is able to repair itself? I mean, how do you write that code? I mean, again, I'm zero knowledge about, I understand the leukocytes. I don't understand how that translates into a code.
Yeah, well, our mentor, Dean Bushley, he was explaining that we could start off by allowing the antivirus to do the thing that every other antivirus does, and read the code and detect words that are already on the list. So what we're trying to, so we're going to take that code like any other antivirus. We're going to he's going to teach us how to format that code to have a bad boy list like every antivirus would, but also to be able to see anything that is foreign. So that's what we're going to, for the rest of the semester, that's what we're looking at. Formatting that antivirus code. What is that antivirus that everyone is using? How could we format it to, detect anything foreign inside your code? That's what we're going to do for the rest of the semester.
Awesome. So what's the possible output that we can see? Can we see the self-repairing anti-worm, whatever you call that? Will that be possible, or
it's very possible.
Is it?
Yeah,
it's not that difficult. Okay. All right.
It's just like a matter of getting. It's like a small child. You just have to learn and learn.
Yeah.
So it's more about experience.
Yeah, because I think virus and worms, however you call it, is a common thing. So everybody knows about that. The thing that you have is the self-repairing part.
Yes.
That's the one that's really new. So if you can show that, no matter how simple, if you can show that it can actually self-repair before it infects another computer. You have two computers there, and you try and show that, then you can have the Shark Tank on your presentation, right? All right, no more questions? No? Okay, thank you guys.